Good day, sir. We are the Group 1, and today we are going to do the final experiment for this semester, paper chromatography. It is a separation technique that involves applying a small amount of sample near the bottom of a strip of paper, which is then dried and placed in a developing solution. The solvent will then flow across the spot through capillary action, and different components of the mixture will move at different rates along the paper as manifested by the stains of color. We have the retention factor that is determined by using the distances covered by the stains over the distance traveled by the solvent. To start, let us first be sure of our attire and equipment so that we are good to go with the experiment. All the members have worn their personal protective equipment for this activity. Then let's proceed to the materials. We're going to need clear glass or plastic canister with cap, Oslo or drawing or sketch paper, pencil, ruler, cellophane, rubber bands, scotch tape or clips, markers of different brands, rubbing alcohol, nail polish remover, or acetone. And for the procedure. First, for the solvent or mobile phase. First, we are going to mix 5 milliliters of acetone and 10 milliliters of 70% rubbing alcohol into a glass canister. Pour contents into a different bottle and stop the pouring when it reaches 8 centimeters level. Cover it tightly with cellophane or its bottle cap. For the sorbing medium or the stationary phase, cut a strip of Oslo or drawing or sketch paper around 5 centimeters width and its length equal to the height of the bottle or glass. Use a pencil and draw a horizontal line 1 centimeter from the bottom of 5 centimeters width paper strip. Divide the horizontal line into 4 and mark the inner divisions with dots. For the separation, take 3 different brands of marker pen of the same color. Use the markers to mark the dots on the strip. Let it dry for 3 minutes. Place the marked strip straightwise on the glass bottle containing the solvent. Fix the other end of the strip with pencil and tape or clip. Cover the head part of the bottle with cellophane and fix it with rubber bands. Allow the solvent to travel upward by capillary action until it stops near the topmost part of the strip. Remove the paper strip and draw a line where the solvent stops. And finally, let the paper dry for some time. That was the procedure, and here are the results that we obtained from the experiment. In marker 1, indigo, and in marker 3, pink, respectively, both of them have the highest affinity to the mobile phase. In marker 2, purple has the highest affinity to the mobile phase. In marker 2, red has the highest affinity to the mobile phase. In all of the markers, indigo has the highest affinity to the mobile phase. In marker 1 red and in marker 2 yellow, respectively, both have the highest affinity to the mobile phase. That would be all, sir. Thank you very much, and Merry Christmas!